Okay, so in our last installment, we were going over the trench to the Trimetric, and that is completed. Trench lines, as you've seen in a previous video, they come out of the shed, and they run through the ground. They're all buried. Our Trimetric wires come up through this conduit, and additionally, I don't know if I could take this off, not right with a screwdriver, but through here, again, the Trimetric wires are going to go, and they go right onto the cabin, those sensing wires. And then I have my DC MC4 cable that's just sitting in here. It's not energized at all. It's just pre-wired, because I'm going to probably throw in a panel or two later on up there just to get a little extra. The shed is tapped, and even though I didn't run out over the winter, I don't want to take a chance. So anyway, this is completed. So I'll take you inside, and there's our mounted Trimetric. So this obviously lets me track everything I need to track with respect to our power consumption and production. And if you're completely off the grid, as we are, this is critical. One other point about the Trimetric wiring. With the sensing wires, there's 4 of them. I may have said 3 before, but there's 4 of them that come in here, and you saw them before I just closed this up. You should braid them in some fashion, or twist them to prevent any RF interference or interference from other lines, because they're very sensitive. They're measuring milliamps, and you don't want anything to throw that off. Now, ironically, I didn't braid mine. I used a thicker gauge, and even though they're being run in that deep conduit, let that focus, well, you can't even see it, but it's underground, that deep conduit with a ton of other wiring, I think because I used a thicker sensing wire, just a higher gauge, I haven't had the problem. But I have the same thing at my house, and I've had problems with it until I braided it. But this one I've been running for 8 months, not a single problem. It's not braided. But just a tip, though, anyone that's doing these, you want to probably braid them just to be safe than sorry. Okay, so now let's go over the inverter and the inverter wiring. So let me go back in to the shed, and I'll show you. Okay, so first of all, the inverter, I've already showed how this was wired to the battery bank. I used the DC combiner box. It's not a combiner box, the DC breaker box. So all these components, beginning with the solar coming in, everything is run through these breakers, including ground fault protection, and then a big 250 amp breaker to protect the battery overcurrents. And then this too goes through its breaker. I'm not going to go over that again because I think I have that in the prior video. But the wiring, once you've wired this, and it's just your positive and negative. In fact, let me take it off. I'll take off the... Okay, now with the face plate removed, here's the, just go over the DC, well, I'm sorry, the DC and the AC wiring. The DC wiring I already did in the other video. It's pretty simple. It's your positive, your negative. These guys run, for me, through this little conduit into the DC breaker box, runs through its own breaker, and then to the battery bank. So obviously this inverter is being energized by the battery bank. It's taking my 24 volt battery bank and inverting it to 120 volt AC. Now the AC power is now going to have to run into the cabin. And here's what I've got. I'm using 6 gauge. So you've got your hot, you've got your green, your ground, and then you've got your neutral. This is pretty simple. I don't know if I can see this in here, but yeah, I think you can. There's up top here is where you would terminate your AC in or your AC out. Now, I don't have any AC in. If I had AC in, then you know, that would be, let me pause. Okay, sorry about that. I don't have any AC in, but these can be wired to have AC in, and all that would do is it allow your AC power, whether that's coming from a grid or from from a generator, to come in and then basically use this as a charger to charge your batteries. But for me, I'm off grid completely. I don't have any grid power coming in. So for me, it's just straight AC out. Again, it's taking the battery bank, converting it to 120 volt AC, and it's running right now through these wires. So this is my hot, it's my green ground, this is my white neutral. This runs back out. It's also grounded, equipment ground. I'm not going to go over that right now. That's a whole nother video in itself. But these three are going to, and this is 6 gauge because I got a pretty good run and I wanted to oversize the wires. But this is 6 gauge. It's going to run through. You can see it coming out of the and goes out of that conduit, and it's going to go underground, and I'll take you to where they land. All right. I'm walking on top of them. You can see right there is where they come out from the ground. I have them come up. I have them go under. I still have to attach that against the retaining wall. And then I have it come back up through here. And a little offset I put in here. And I have them come up. This whole breaker panel for my cabin is 120 volt. So your 220 wiring might look a little differently. But the inverter's a 120, so that's always going to be 120 unless you're stacking inverters and stuff like that, which we're not getting into. But so here I've got my 120. Here's the hot coming up. Here's your neutral. Here's your ground. Hot's going to terminate into a breaker. I put it into a 50. Your neutral and your green are going to land onto your neutral ground bus bar, bond, and then these are ultimately through this electrical panel that was existing here. It's bonded to earth. Obviously, if this is a sub panel, you would have to separate out your neutral, your ground. This isn't. This is really simple. This is as easy as it gets. So anyway, back to the hot. The hot's going to terminate. I used a 50 amp breaker. You want to use the breaker size that makes sense for the inverter and what the inverter can put out. My inverter's it's the 3524 Outback model. That means it's 3500 watt inverter. But your surges are going to be 5, 6, 7, 8,000 watts. Rare for me to ever surge above 6,000 even. So I basically, I'm looking at my normal continuous loads. I could have went with a 60 amp. I went with a 50. And you could do the math. It's pretty much going to cover me 99% of the time. And then 1% if I have a demand in a load that's bigger, some surge, it's just going to pop your breaker. That's not a big deal. Ultimately I'm going to get rid of this old piece of crap box. This is all ancient wiring, and it kind of makes me nervous. Half the plugs in this cabin aren't even grounded, so I'm going to have this thing. I'll probably hire an electrician to do that. It'd be a big job, not a do-it-yourself deal. unless you really know what you're doing. But anyway, but this is how it works. So it's your hot from your inverter is going through a breaker. Obviously, if this is on, and then it would energize all the breakers on your bus. I've got 1, 2, 3, 4 breakers. Small cabin, so there's not really many breakers in here. I mean, I could add more too. Also, let's see, what else did I want to point out? I think I've pretty much covered this. Just say a quick thanks, shout out to Romo, who helped me out with, wiring the